We are back from commercials. Life is good. So there's a lot happening here. What's the plan? There's no plan. We get in there, we hope for the best, and yeah, muveriku. Okay, but otherwise, just basic objects, man. We'll just go with the flow. I click, I move on. Let me just say, what are objects? They are things. Yeah. Let's make it easy to modify parts, to modularize, to maintain, to exclude and add and extend features. Ish. I don't want to go too deep. This video was 22 minutes. It was a bit long. I don't like that. But there are properties and behaviors. So properties are like variables or pieces of data within an object. Like by the way, an object is a data type. Just so we're clear, just so we're on the same page. Let me do this. I struggled with this some years back. They say objects are data types. I was like, what? I'll make sure that you don't strike. Okay. Open in a new tab. You want this one to go a full image. Yes. So we have primitive data types. Now primitive tend to have a certain size. Java sizes of primitive data types. Do we need to know the sizes? But it's fine. Yeah. Like with float and yeah. Okay. A byte is the smallest thing you can have, smallest data type you can have, and it was back in the days when computers were the sizes of houses, entire floor of a building, and then they ran on magnetic tapes, and then you had like 16 kilobyte RAM. Life was tough, and now you have shorts that. Oh, it's 8 bits, by the way. It's 1 byte. 1 byte, it's 8 bits. So when they say a thing runs at, let's say 500 kilobytes, how do I say this? Divide that by 8. 500 kilobits. You divide that by 8, and then you get the megabyte, the kilobyte version. Basically moving from byte to bit, divide by 8 each. So 8 bits, 1 byte. Yes. Yes. 8 bits, 1 byte. Had to think of that. Now things got a bit more complex. We got more memory, technology improved. Transistors are the size of less than a human hair at this point. Life was fun. That's the whole history of a computer. Transistor was big, it was a switch, it was a bulb. Now it's a small teeny gate with lines and then holes and leaves charge, and then stores it that way and then stores it the other way. Now you know everything about computers. Congrats, you deserve a degree. And then from short we went into long, that can store the negative of that number, the positive of that number. Go use a calculator, you'll find it. Long, yeah 16 bits, 64 bits. By the way, a float and a double are the same thing, but then a float holds twice as much, or takes up twice as much of the size of the float. That is whereby you need a bit more precision. Hey, anywhere between 0 and 65 grand. And then a boolean is basic. That's a live transistor, on or off, nothing more. Now, those are the primitive data types. Back when computers were just, everything was just a number. Even characters are numbers. Now we're getting to the fun parts now. ASCII values, and to see that even characters are numbers, there's a system called an ASCII table. Why are we dealing with bad quality? Why? Aye, man. Okay, let's go to the first one that we see over here. This is the system. You can find higher numbers, you can find lower numbers, but then this is it. Your 1 is a 49, your 2 is a 50. That is, if you can see, 3 is 51, and so forth. Where parents are calling. Ame mpema 20 ele gatla mo within 20 minutes nyana tla ba kufeditse. Yebo ba sala wana. I'm sure ele ka tswa no tla ba ke repa apa itswe. Ele ka no tswa no so ele fitla mo tla ba ke feletsa itswe. Oh, next how go sharp. Okay, ksa record as we speak no so. Okay, sharp. Ta-da. Okay. We are back. For those who understand Betty, that was a bit of a show for you. Or called Beloved Parents. For those who do not understand Betty, in conclusion, my parents love me. Anywho, every character, every symbol has a number. So this is everything that there is. Primitive data types. These ones are complex. These ones are objects. The strings, your arrays, your list, your sets, your stacks, vectors, dictionaries, and so forth. Now, like an integer just holds a value. It's 5 or it's 50 or it's -1000 whatsoever. There's nothing much to it. A double is a double. Like character is a character. That's it. Now when you go into a string has a value. It has length. String we dot why can we let me do this. We dot no, there has to be more. Java string documentation should be gone by now. Yeah. Okay. Objects are, these are all the fields, by the way, and all the arguments and all the constructors. You can join strings, you can get its bytes, you can find the character add. These are all its methods, by the way, its tendencies, its behaviors, things you can invoke to get certain parts of the data back. So it is a data type, yes, but it does a whole lot more than just being a data type. You can check if it's equals to something. You can check the index at a certain point. You can check if it's empty. You can join it to something. You can find the last index. You can find its length. You can turn it to string. Yes. You can find the value of Uh, yeah. So where we at? Okay, we go back now. We go back. So that's why we say objects are data types. These are data types. Primitive data types are data types. Non-primitive data types are also data types, but then they are objects. Primitives, simple, basic. Non-primitive, they have depth, they have complexity, and so forth. So when I say an object is a data type and a data type is an object, I mean they have values, they have tendencies, they have methods, they have behaviors. So it can have a value of 5, but then it can turn that 5 into like an ASCII value, and then it will give you a letter, or it has a certain index or a certain size. Those are methods. You invoke them, and then they give you something back. They return something. So that's what it means. They have behaviors. It means they have methods. Properties, that means they have data or fields. Behaviors, they tend to change something or return something. Definitely one of the two. Properties are just data. What's its size? What's its shape? What's its name? What's its color? Behaviors, you can shop for something, you can put it in an item, you can pay. We're flying. Seat belts must be tight, or else you're flying off the plane. Should I just do this and leave? Probably. You just saw me use the dot operator. I will not go into that one, because once you press dot, it gives you access to its methods and variables. Yes. By the way, an array can hold an object can hold arrays. Don't want to go too deep. Time is not on my side. Let's do this. You see this one? This one I don't like. I don't like at all. Okay, let's do this. Yeah, love this thing. I love, and I think people stopped developing it a while back. Okay. Let's do this. Yeah. Okay. Now we have a customer. His name is Junior Duke. It's a data type of type custom. His name is Duke, and he has a customer ID of 1205, and he has an address. It's declared, but it's not initialized. Same goes for the int and the age. What is happening? And then we have a method called this thing, display customer. How do we declare a thing again? We I shall look for initialize string in Java. Yeah, this is what I look for. We in times of need. But you forgot the most basics of basics. Do this. Just copy the same format that is above. So customer, we you customer, bam, lovely. Now customer is a thing. As a method, let's use that method and wrap it up. I'll call it a day. Not much else is happening in this chapter. It's a lot, but it's not much. A lot, but not much. It has depth, but not specifically quantity, if that makes sense. Chief. Wait, does he have a name? He has a name. I will not lie. I will not be solving this. Oh, let me do this. Wait. Okay. But the problem is 19. No, I'm going to have to end it here. We have declared an object, though we have not used it. We'll use it in the next recording. You see, no errors. Time is not on my side, unfortunately. But yeah, this is its methods. These are its fields. We'll edit the things later. It's been good. It's been nice. Enjoy your day. Love you.